Most teams trust their fabric model as truth. It is not. Your DAX looks like analytics, but architecturally it's a distributed decision engine running without your intent. That distinction matters, because once human-authored logic starts deciding what's visible, you're no longer enforcing access, you're inferring it at runtime. Here's the uncomfortable truth and the fix. I'll walk through 5 repeatable failure modes that make this inevitable, then show the deterministic controls that stop it. You'll leave knowing which decisions are illegal to make in DAX, and how to enforce your assumptions at the control plane so your model can't drift. Case 1. RLS bypass via measures when totals leak. Most organizations celebrate the first time row-level security works in testing. The right rows disappear, the demo looks safe. They are wrong. What RLS does is constrain base tables. What your measures do next is an authorization system of their own, written by analysts, executed by the engine, and never reviewed by identity. This is where totals leak. You build a perfectly reasonable page, a summary card for total sales, a bar chart by region, and a KPI that flags significant variance. RLS filters the rows to east, as intended. But the measure isn't just summing a column. It's iterating, revising filter context, and sometimes reaching around your security boundary via CALCULATE and SUMX. If one branch of logic evaluates a broader scope, even briefly, you've created a side channel. No alert fires. The result looks like analytics. Auditors later find an inference path that reconstructs a restricted total by subtraction or variance across visuals. The thing most people miss, SUMX and CALCULATE are policy engines in disguise. They are not just math. CALCULATE rewrites filter context. SUMX loops through a table, changing context row by row, and invokes other measures inside that loop. In other words, your aggregation is a distributed decision program operating after RLS. You did not disable RLS. You described an alternate view of the world the engine is free to compute. This clicked for me the first time an internal review asked a simple question. Can a user with access to only east deduce west if they can see any all-up total anywhere? The answer hinged on one measure. It used CALCULATE with all to normalize a benchmark. That normalization effectively invited data from outside the user's security scope, producing a number that could be joined with visible partitions to infer the rest. The report never displayed west directly. It didn't need to. The math exposed it. Here's why this happens architecturally. RLS is not the boundary. Measure semantics are. The tabular engine evaluates measures in filter context, and your code can alter that context. All except, remove filters, cross-filter, treaters, these functions reshape the decision graph. You can craft a measure that computes across an entire table, then present only one slice of it visually. The numbers still carry the weight of the unfiltered scope. That's conditional chaos. A security model drifting from deterministic to probabilistic through innocent-looking logic. Now here's the shortcut nobody teaches. Treat authorization-adjacent DAX as illegal. If a measure changes visibility, rows, columns, or classification, it is acting as an access control. That belongs to identity, not DAX. If you remember nothing else, remember this. DAX must never decide who can see data. Identity must. Let me show you exactly how to reason test a measure. Ask 3 questions. Does any branch of this logic remove or bypass filters on protected domains? Look for all, remove filters, or filters that reference sensitive dimensions. Does the measure compare a scoped value against an unscoped benchmark? If yes, you've created a leakage path by subtraction. Does the measure rely on totals that are not RLS scoped identically to the visual? Mismatched scope is an inference engine. Once you nail that, everything else clicks. You refactor measures so benchmarks are computed upstream and labeled. You refuse normalization that crosses identity boundaries. You ensure any global totals are computed and stored in a domain where identity has already decided who can query them. Now here's where most people mess up. They try to fix this with training. They create a style guide. They run a brown bag on safe DAX. And then the model grows, velocity wins, and one helpful exception sneaks in to just get the dashboard out. That exception becomes a pattern. Entropy accelerates. You're back where you started with a smarter looking leak. The deterministic stance is different. You enforce the boundary outside DAX. Entra handles authorization. Purview's sensitivity labels veto reuse. They don't annotate it. Data loss prevention blocks exfiltration paths at the edges, exports, notebooks, composite models, shared datasets. Capacity isolates blast radius so failures stay local and investigations stay bounded. Identity compiles intent, DAX consumes data. They are not the same task. Microstory. Last quarter, a team shipped a revenue view with RLS by region. A variance to plan measure used remove filters date to stabilize seasonality. It looked harmless. In audit, we swapped the plan table for plan by region. Variance flipped into an inference tool. Users could derive other regions' plan deltas by comparing my region to the stabilized total. RLS was working, intent was not. We removed the measure, pushed plan aggregation upstream, and enforced a label that blocked any model from introducing a cross-region benchmark without a control plane approval. The game changer nobody talks about is this. Once you declare certain DAX patterns illegal, you simplify the entire review surface. You move from probabilistic assurance, looks fine in dev, to deterministic enforceable rules, cannot exist in prod. And boom, look at that result. Total stop leaking, not because people got better at DAX, but because DAX stopped being allowed to act like an authorization engine. Now that RLS works, calculated tables will still fork your truth next quarter. That's the next failure mode. Case 2, semantic model drift via calculated tables. The second place organizations congratulate themselves is when the source system is clean and the star schema is approved. They believe the model is anchored. It is not. The moment a calculated table lands in the semantic model, you've created a parallel rulebook that nobody upstream can see, govern, or retire. That distinction matters. Here's the failure pattern. A team needs a quick products in market slice that joins today's catalog to last quarter's launch window and a marketing eligibility flag. Instead of asking the data platform to publish a governed dimension, they write a calculated table in the model. Select columns, add columns, a filter here, a union there. It loads instantly. Visuals light up, velocity wins. You now have a shadow dimension that encodes business logic outside lineage and outside labels. That table becomes a join partner and quietly redefines reality. What most teams miss is simple. Calculated artifacts are entropy generators. They duplicate structure, embed decisions, and break inheritance. Sensitivity labels from Purview don't propagate into the calculated result the way you assume. Lineage shows a tidy arrow, but it's theater. Lineage is evidence, not assurance. It tells you where the data moved, not whether your new definition stayed compliant with policy. Over time, these tables accumulate: canonical reference catalogs, date helpers, eligibility bridges, each one slightly different, each one disagreeing by one edge case. Drift stops being accidental. It becomes structural. This clicked for me when a model review surfaced two numbers for eligible customers. One came from the warehouse view, label confidential. The other came from a calculated table that tweaked eligibility for a campaign. Both were right for their authors. Neither could be safely deleted. The calculated one had bled into measures and visuals across 5 workspaces through shared dataset reuse. We could not audit who could see what, when, without replaying human intent spread across dozens of DAX expressions. That is security debt created by convenience. Now here's where most people mess up. They treat calculated tables as just-in-time modeling. It's faster to build here. It is faster. It is also governance bypass. The model becomes an authoring surface for business rules that should have lived upstream, where identity, labeling, and DLP can veto them. When you compute the rule in the semantic layer, you grant analysts the power to redefine classifications, rewrite keys, or stitch domains without the control plane ever seeing it. You are not misconfiguring fabric. You are omitting design. Architecturally, this is why drift is inevitable. The semantic model is a consumer. It should bind to governed definitions. When it produces definitions, it forks the truth. Every fork dilutes enforcement. Labels don't propagate deterministically across a table, synthesized from multiple inputs with mixed classifications. Joins materialized in DAX don't inherit the same identity boundaries that Entra enforces at the source. And because calculated tables feel harmless, just DAX, just data, they slip past review. These pathways accumulate. The deterministic stance is ruthless. Business definitions live upstream. The model consumes, never redefines. If the warehouse lacks the construct, you add it there. If the domain team won't own it, you do not ship it. That is not dogma, it is boundary enforcement. Upstream is where identity compiles intent, Purview labels, veto unsafe compositions, and DLP policies can block downstream reuse. If a control cannot stop a model from existing, it is not governance. Let me show you exactly how to test for drift. Ask 3 questions. Does this calculated table encode a business definition that exists, or should exist, upstream? If yes, it's illegal in model logic. Does it join or union across domains with different sensitivity labels? If yes, you've created a classification override the label system can't see. Does any downstream measure rely on this artifact to scope visibility? If yes, you've mixed authorization semantics with analytics again. Once you see that, everything else clicks. You refactor, disallow calculated tables for domain logic, restrict them to harmless scaffolding only under controlled review, or ban them entirely. You route requests to data engineering, where labels, lineage, and identity live. You codify this in publishing policy. No publication when calculated artifacts of prohibited categories exist. Block at build replaces fix in review. A microstory, a finance team needed active agreements with a retailer-specific carve-out. They built a calculated table to filter out dormant SKUs and applied a geographic exception for one chain. It worked. A month later, an audit flagged inconsistent counts across regions. The calculated artifact had been copied into a gold workspace and shared as a golden dataset. 2 truths existed, both certified. We killed the table, pushed the definition into the warehouse, attached a highly confidential label that prevented cross-tenant reuse, and added a DLP rule preventing export for any model referencing that label. The count stabilized, the blast radius stayed local because capacity isolation kept finance models off shared capacities. The game changer nobody talks about is this. Once you prohibit entire categories of calculated artifacts, the model's surface area shrinks to analytics. Exceptions stop compounding. Upstream definitions become the only pathway. You gain something rare in BI, delete safety. You can retire logic in one place and know you didn't leave an undead copy in 1,000 PBX files. Even with perfect sources and no calculated tables, teams will still point to Lineage when decisions drift. That's the next failure mode, Lineage theater, because arrows do not enforce policy. Enforcement does. Case 3, Lineage theater, pretty graphs, no guarantees. After you ban calculated artifacts, someone will hold up Fabric's Lineage view as proof you're safe. The arrows look authoritative. Sources flow to transformations, to lakehouses, to semantic models, to reports. Confidence returns. It should not. Lineage is a narrative. Enforcement is a control. Those are not the same thing. Here's the failure pattern. A regulated dataset enters one lake with a confidential label. A data flow refines it. A warehouse table feeds a semantic model. The lineage graph shows a clean path from origin to consumption. Meanwhile, an analyst connects a notebook to the model, materializes a helper parquet for a side analysis, and re-imports it into a different workspace as benchmark. The arrows don't render that detour with the same weight or timing. Sensitive data has crossed boundaries, and the map still looks pretty. The thing most teams miss is simple. Lineage is evidence, not assurance. It's post-facto storytelling. It can tell you where data moved. It cannot tell you whether your policies were enforced when it moved, whether labels persisted intact, or whether identity boundaries held when logic fused domains. If enforcement is optional, theater grows. The graph gets denser, risk becomes decorative. This clicked for me in a privacy review where every box was green. The lineage showed customer data sourced from a governed lakehouse, transformed by a certified data flow, landing in a certified semantic model. Perfect, except a top accounts table existed in the model, created by importing a CSV exported from a prior version of the same model. The lineage omitted the export import because it occurred through a user device and a temporary workspace. The arrow missed the policy violation. The report did not. Now here's where most people mess up. They treat Lineage as a guardrail. It is not. It is a dashboard. You cannot prevent a car crash with the speedometer. You can only measure the speed after you've chosen it. The governance stance has to invert. Labels and DLP veto unsafe flows in real time. Lineage explains what happened later. If a label can't stop a model from being published, that label is decorative. If DLP can't block a notebook from writing a sensitive join to an ungoverned folder, your edges are ornamental. Architecturally, this is why guarantees fail. Fabric connects heterogeneous planes, control, data, compute. Each has its own decision surface. A lineage graph stitches metadata across them, but not every hop is instrumented equally, not every path is synchronous, and not every consumer is visible. Notebooks, exports, composite models, shared datasets, these are access planes masquerading as convenience. The map can't enforce intent because it doesn't own the enforcement points. Purview does, Entra does, DLP does. If those are not configured to veto, the arrows are just arrows. Let me show you exactly how to treat lineage correctly. 3 rules. Assume every arrow is a hypothesis. Verify with enforcement. Sensitivity labels must persist across the hop and block operations when they don't. Test it by attempting the prohibited action and expecting a failure. Treat off-graph flows as the default threat. Any export, notebook write, or cross-workspace reuse must encounter DLP at the boundary and conditional access at identity. If you can't force that check, you do not control the edge. Use lineage for impact analysis, not comfort. When a source changes, you trace who breaks. When an incident hits, you reconstruct blast radius. You do not assume safety because the graph looks clean. A microstory. A health analytics team proudly showed full lineage from EMR extracts to a de-identified encounters model. Labels looked correct end-to-end. During a drill, we asked them to export a small slice for a vendor model test. The export succeeded because the label policy annotated it didn't veto. The CSV was re-imported as a synthetic benchmark in a separate workspace. Lineage showed a new node, post hoc. We flipped the policy, label blocks export for that classification, notebooks, writing tables inherit and propagate labels, DLP intercepts cross-workspace imports with confidential payloads, and conditional access forces compliant devices for any lakehouse write. The next export attempt failed closed. The graph didn't change much. The system did. The game changer nobody talks about is this. Once you stop treating lineage as a control, your design changes. You move decisions to the control plane. Labels define what. DLP enforces how data leaves or persists. Entra decides who. Lineage becomes what it always was. Evidence. Useful. Informative, but never a guarantee. Case 4. Shared dataset plus cross-workspace access. You fixed calculated tables. You stop trusting lineage. Then someone proposes the golden dataset. One semantic model to rule them all, shared across workspaces for consistency. It sounds efficient, it is an access plane. The moment you reuse a model across workspaces, you erode the very boundaries you thought you were enforcing. Here's the failure pattern. Finance publishes a certified revenue core semantic model in a controlled workspace. Product, sales, and ops build thin reports against it from their own workspaces. To speed adoption, an analyst adds a few convenience roles in the shared model, plus a couple of broadly scoped Entra groups so everyone who needs it gets in, it works, queries flow, dashboards ship. 3 months later, an audit asks a simple question. List every user who could access rows labeled highly confidential for region X on the evening of June 5th. You can't answer because identity scope now spans multiple workspaces, each with separate sharing, each with local report level filters, and each with its own set of temporarily added users that never got removed. The golden dataset dissolved your boundary. The thing most teams miss is simple. Cross-workspace reuse is not a convenience feature. It's an access plane. When you point a report in workspace B at a model in workspace A, you didn't just reuse metrics. You created a new path where users, service principals, and groups in B can induce queries against A. If inheritance semantics between the control plane, workspaces, roles, sharing, and the data plane, model permissions, RLS, don't match perfectly, and they never do, you've now got inferred trust, replacing explicit authorization. This clicked for me during a permissions review. The shared model had tight RLS by region. The consuming workspace had a Power BI app with build permission granted to a team group that included contractors. Contractors could not view the app content, but build permission was enough to create a new report that bound to the shared dataset, publish it to a different workspace, and request access there through a different owner who assumed group membership implied vetting. Intent dissolved across boundaries. No breach, no alert, just architectural erosion. Now here's where most people mess up. They try to manage shared dataset sprawl with naming conventions and wikis. They write who should use this on a Confluence page and hope it sticks. Or they centralize ownership in one admin who approves every access request. It works until it doesn't. Velocity wins and exceptions pile up as temporary. Those exceptions are entropy generators. Over time, your golden dataset becomes a federation of implied contracts you never encoded. Architecturally, this is why the boundary fails. Workspaces are control plane containers. Datasets are data plane objects. Reports in other workspaces create new authorization contexts that your original workspace never sees. Even if RLS holds, the identity graph expands. App audiences, build permissions, share links, service principals, and cross-tenant B2B guests. And remember, the engine evaluates measures under whatever filter context the consuming report supplies. If that report introduces global benchmarks or helper pages that compare scoped values to unscoped ones, you just reintroduce the inference problem from a different angle, now scattered across teams you don't manage. The deterministic stance is uncompromising. Enforce boundaries at Entra group and service principal level. No implicit reach-through. That means a few hard rules. The only identities allowed to query a shared dataset are explicitly enumerated Entra groups that you own, review, and recertify. No nested everyone groups, no ad hoc shares, no email addresses. Build permission is not a shortcut for trust. If a user can build, they are in scope for query. Treat build as equivalent to may execute arbitrary DAX against this model. If that's not acceptable, they don't get built. Consuming workspaces do not extend authorization, they project it. If the consuming workspace contains users not in the dataset's approved groups, the connection fails closed. No inherit from container semantics, no app audience implies data access. Let me show you exactly how to reason test a shared dataset design. Ask 3 questions. Can any consuming workspace add a principal who is not present in the dataset's Entra groups and still induce queries? If yes, you have reached through. Does any consuming report introduce measures that compare scoped values to all values from the shared model? If yes, you've reopened an inference channel. Is there a service principal with build rights used for automation? If yes, confirm its app role is scoped to the same groups enforced by RLS, or you've created a machine bypass. A microstory. A retailer standardized on a shared store performance model. Marketing built thin reports in their workspace. To drive a campaign, they granted a vendor service principal build access to bind data into a PowerPoint generator. The principal wasn't in the model's region groups. RLS still filtered row visibility, but the automation rendered a cross-region trend by using measures that normalized against remove filters store. The vendor never saw individual stores. They saw a decorated trend line that, when compared to their own regional data, allowed back calculation of competitor deltas. Nobody intended it. Everyone assumed build wasn't view. It was both. The game changer nobody talks about is this. Once you treat cross-workspace reuse as an access plane, you change the defaults. Shared datasets live behind dedicated Entra groups, no nested membership, quarterly recertification. Service principals are workload identities with conditional access and kill switches. Consuming workspaces get zero authority by default. Build is gated by the same groups as view. And when a team insists on a local convenience measure that compares scope to unscoped, you don't argue style. You block publication until that logic lives upstream where identity has already decided who may see the result. You are not misconfiguring Power BI. You are refusing to let convenience become your authorization model. Boundaries aren't labels or arrows. Boundaries are identities evaluated at runtime, enforced by design. Case 5. DAX exception sprawl. The patchwork semantic layer. You banned calculated tables. You lock down shared datasets. The arrows no longer lull you. Then the sprawl begins. Not with a breach, but with a favor. We just need a one-off measure. It ships, it works, it stays. 6 months later, the semantic layer is a quilt of exceptions nobody can read, nobody can test, and nobody can retire. Here's the failure pattern. A report needs a clean profit margin that excludes promo SKUs. Another team wants a net revenue that smooths returns over a rolling window. A third needs active customers with a carve-out for trial periods. Each request is reasonable. Each becomes a local measure with a slightly different definition and a slightly different escape hatch. Review never happens because there's nothing obviously malicious, just math. Over time, those one-offs crystallize into patterns. Helper measures that normalize across remove filters, convenience flags that backdoor classification, total versus my scope comparators that reopen inference, dynamic format strings that encode sensitive state and visuals. The model becomes an authorization patchwork disguised as analytics. The thing most teams miss is simple. Exceptions are entropy generators that never retire themselves. Readability is not control. A pretty measure name and a comments block don't enforce anything. Libraries without policy are accelerants. The moment you centralize a helper measure and publish it as reusable, you've industrialized the exception. 1,000 reports can now invoke a logic path that was never vetted by identity, labels, or DLP. That is how semantic layers turn into decision engines you didn't design. This clicked for me during a deprecation exercise. We tried to remove net revenue edgy, created 2 years prior to handle a promotional anomaly. It lived in 4 workspaces, had 8 variations, and fed a KPI used by finance, marketing, and operations. Each copy diverged subtly, different date windows, different product filters, different fallback behaviors when plan tables changed. We couldn't kill any of them without breaking good reports. We weren't refactoring DAX, we were unwinding organizational folklore embedded in formulas. Now here's where most people mess up. They attempt to fight sprawl with linting and code reviews. They add naming conventions, folder structures, a helper table of standard measures, and a request form. It slows entropy for a quarter. Then velocity wins, a deadline arrives, someone copies a measure, tweaks one line, and ships. Exceptions compound because your controls are advisory. They don't fail closed. Architecturally, this is why sprawl is inevitable in a permissive system. DAX is a functional language with powerful context manipulation. It can represent authorization-adjacent logic succinctly and spread instantly via copy-paste or shared libraries. Without a policy compiler that forbids entire categories, you can't prevent the same anti-pattern from reappearing with a new name. Every library you publish without a policy manifest becomes a distribution channel for ambiguity. Every temporary measure becomes an immortal. The deterministic stance is blunt. Prohibit categories of logic in DAX. Ban authorization-adjacent measures outright. If a measure alters visibility, infers across identity boundaries, rewrites business keys, or overrides classification, it cannot exist in the semantic layer. You don't review it, you block it. You relocate the need upstream where identity, labels, and DLP can adjudicate. And you drive the rest through libraries with policy manifests, not just code. A manifest declares the allowed filters, the sensitivity scope, the identity assumptions, and the failure mode. If the assumptions aren't met, the build fails. Not a warning, a veto. Let me show you exactly how to reason test for sprawl before it metastasizes. 3 filters. Name gravity. If a measure's name invites reuse, net, adjusted, normalized, assume it will spread. Treat it as policy, not convenience. Scope mismatch. If any branch compares scoped values to unscoped totals, it's an inference path in disguise. Illegal non-classification distortion. If dynamic format strings, icons, or SVG encode sensitive state that RLS or labels would otherwise hide, you've created a leakage channel. Ban it. A microstory. A sales ops team published pipeline AGI to exclude internal transfers from forecasts. Marketing loved it, copied it, and added a brand filter. Finance forked it, switching to fiscal calendars. Within weeks, 3 adjusted pipeline KPIs disagreed by single digits in executive decks. Nobody knew which was canonical, and one variant used all date to stabilize seasonality, reopening an inference path across regions. we pulled the plug. The adjustment moved upstream into the warehouse with a highly confidential label. The library got a manifest, allowed filters, fiscal alignment, and a hard stop if a report attempted remove filters over protected dimensions. Build broke until they complied. The disagreement disappeared. So did the side channel. The game changer nobody talks about is this. Once you outlaw whole families of DAX exceptions and require manifests for reusable logic, the semantic layer stops being a patchwork. Measures return to analytics. Policy returns to identity. Sprawl doesn't slow, it fails to exist. Illegal in DAX, decisions that must fail, closed. Before we fix anything else, we have to draw the red lines, not preferences, not best practices, illegal categories, because ambiguity is where entropy grows. If a measure can change what's visible, infer what's hidden, or rewrite what identity already decided, it cannot exist. These are the decisions that must fail, closed in DAX. Prohibit visibility changes encoded in measures. Anything that expands or contracts who can see rows or columns directly or by proxy is an access control. That includes patterns that do the following. Remove filters on protected dimensions using all except, or remove filters. Conditionally mask values based on slicers when the slicer scope differs from identity scope. Or fabricate helper totals that aggregate outside the viewer's RLS. Architecturally, these aren't aggregations, they are alternate worlds. If you need a global view, compute it upstream under identity and publish the result as a governed artifact. DAX consumes visibility, it never defines it. Prohibit security context inference via aggregates or conditional masking. If a measure can compare my scoped value to an all value, you've built a subtraction engine. If it can flip format strings, icons, or SVGs based on a hidden state, you've encoded a covert channel. The shortcut nobody teaches is simple. Any comparator that crosses identity boundaries is an inference tool in disguise. The engine is happy to compute both sides. Your RLS won't stop the math. The only safe version is one where both operands are produced upstream in a domain already decided by Entra and tagged by Purview. If that's not true, the measure is illegal. Prohibit business key rewrites that bypass lineage and labels. Calculation shortcuts that stitch keys across domains, concatenating region and month, coalescing surrogate keys, or reassigning unknowns on the fly are classification operations. They alter how data joins, which alters what rows exist. Upstream is where keys are defined, stewarded, and labeled. In-model rewrites create a side ledger your governance can't see. That distinction matters. If the business key needs a fix, fix it where lineage can prove it and labels can veto it. Prohibit data classification overrides, including format string tricks and SVG encoding of sensitive states. Dynamic format strings can leak confidential classifications, colors for at-risk accounts, icons for blocked vendors, suffixes that imply threshold crossings. If a user can only see a subset of rows by RLS, but the visual signals depend on totals that include hidden rows, you've turned visuals into a disclosure device. The rule is blunt. If a label would hide or restrict the underlying data, the semantic layer may not represent that state indirectly. Either compute a safe, labeled derivative upstream or it does not render. Prohibit cross-domain joins that materialize identity leakage paths, DAX patterns that treat as one domain into another, or that create virtual relationships across tables with different sensitivity or identity scopes, turn a report into a join engine your control plane didn't authorize. Even if each table is individually safe, their intersection might not be. If the join is legitimate, it belongs in the data plane governed by labels, lineage, and DLP, where Entra guards the perimeter and Purview can persist classification across the result. If you can't get that approval upstream, the join is not allowed downstream. Now, how do you enforce illegal in a language that happily evaluates anything you write? You don't rely on human review. You fail builds by design. You lint for banned functions only as a proxy. All, remove filters, cross-filter. Knowing patterns matter more than tokens. You attach policy manifests to libraries, allowed filters, permitted dimensions, sensitivity scope, and the identity assumptions each function relies on. If a measure calls a library outside its declared scope, the model fails to publish. If a report references a labeled table and includes an illegal comparator, the pipeline rejects the artifact. No warnings, no exceptions. Closed by default. This is where the separation of duties becomes operational. Identity belongs to Entra, groups, roles, app, and service principal boundaries. Classification belongs to Purview, labels that veto, not decorate. Exfiltration control belongs to DLP, blocking exports, notebook writes, composite model blends, and cross-workspace imports when labels say no. Blast radius belongs to capacity, isolating risk domains so a mistake does not become an incident. The semantic model sits last in the chain. It visualizes approved reality. It never invents its own. A quick sanity test to keep your reviews short. For any candidate measure, ask, does this logic introduce a perspective the user's identity could not request directly? Does it encode a business decision that shifts row existence or meaning? Does it compare my scope to all scope across a protected dimension? If any answer is yes, it's illegal in DAX. Move the requirement upstream where intent can be compiled, labeled, and enforced, or don't ship it. If you remember nothing else, remember this. Analytics happens in DAX. Authorization does not. When that distinction holds, your model stops drifting. When it blurs, entropy wins. Entra as authorization compiler, enforce assumptions at scale. You cannot fix conditional chaos with friendlier DAX. You have to move the decision to a system that treats authorization like code. That system is Entra. Think of it as your authorization compiler. You write intent once. Who can act, where, and under which conditions, and Entra builds the graph of identities, roles, and policies that the rest of Fabric must obey. Same inputs produce the same decisions. No analyst help at runtime. No drift. Here's the uncomfortable truth. If you don't compile intent before the model exists, you are delegating access to the semantic layer. It will accept the delegation. It should not. Start with non-negotiables. Identities are not people. They are actors. Treat every consumer, human, app, service principal agent as a first-class identity. Then set boundaries. App identities only where automation is necessary. No shared secrets, no one app for everything. Each workload identity has a narrow scope, a revocation path, and a kill switch. If you can't disable it without breaking the world, you built a backhoe, not a tool. Group membership decides authorization, not workspaces, not names. Entra groups are the only doorway into sensitive models. Every group is owned, recertified, and free of nested everyone recursion. You grant groups to datasets. You never grant individuals to reports as a shortcut. Service principals live under conditional access. Yes, machines need policies, device claims, locations, risk signals applied to workloads, not just humans. If the principal can run from anywhere with no friction, you've built an exfiltration path with an API key. This is the foundational mistake most teams make. They try to describe data policy with DAX when they never described actor policy with Entra. Once you nail actor boundaries, you start compiling your assumptions. Conditional access is where most of your "we thought the network was the boundary" beliefs go to die. Replace them. Treat conditional access as the runtime gate for every path to data. Block legacy protocols and non-compliant devices. If a device can't attest, it can't query. Not warn, not educate, must block. This is where fail-closed lives in reality. Risk-adaptive decisions. High-risk user or workload requires step-up MFA or deny outright for sensitive scopes. You're not punishing users. You're preventing helpful automation from becoming your breach. App-enforced session controls. Your builder population is the most dangerous. Treat build permission like execute arbitrary DAX. If they can build, they must be on a compliant device, in a trusted network, and inside your monitored perimeter. If they can't meet those conditions, they can't compile queries. Entitlement management exists to drain exception sprawl from identity. Every temporary access story is an entropy generator until you make it a package with an owner, an approver, a time limit, and an automatic removal. You encode the business reason in the package. You don't encode it in a wiki. Now connect the dots to the semantic layer. The engine evaluates measures in whatever filter context the report hands it. Your job is to ensure only identities you compiled can hand it any context at all. Practically, that means datasets never accept build or view from outside enumerated Entra groups. Consuming workspaces project access, they do not extend it. A user not in an approved group cannot induce a query, even if they own the consuming workspace. Service principals that drive refreshes, exports, or embedding do not inherit human access. They have their own groups, their own conditional access, and their own approval flows. Workload identities are not convenience tunnels, they are bounded executors. Cross-tenant guests are identities. They get the same packages, conditions, and expirations. If you can't express it in Entra, you can't express it with a share link either. Here's the shortcut nobody teaches. Your model access review should be primarily an identity review. If you need a visual to understand who can see what, when, you already lost. The answer should be derivable from group membership, package grants, and conditional access policy. If you can't produce that derivation, the system is probabilistic. Fix identity, then fix data. Kill switch mindset. Every actor must have a rapid, testable path to revocation. Humans leave, vendors change, apps misbehave. If the only way to stop a runaway principal is to find the person who knows the password, you built a time bomb. Validate kill switches quarterly. Don't trust the toggle. Press it. The reason this works is boring. Determinism. Authorization compiled in Entra produces the same answer no matter how many reports, measures, or workspaces try to reinterpret it. You centralize who and under what risk. Purview handles what. DLP handles how it leaves, and Fabric consumes under those constraints. You've inverted the entropy flow. One microstory. A shared customer profitability model served finance and product. Before Entra hardening, 2 app registrations existed, one for refresh, one for monthly export. Both used broad permissions and ran from anywhere. We replaced them with workload identities scoped to 1 dataset each, guarded by conditional access, trusted network and compliant workload, assigned via access packages with quarterly expiration, and backed by a kill switch runbook. When a vendor integration misfired and started pulling confidential segments at 2 a.m., the kill switch ended it in 30 seconds. No debate, no Slack war room, authority had been compiled already. Identity sets the perimeter, next you make decisions vetoable. Purview turns classification into a control, not a caption. Purview as veto, not decoration. Identity compiles who and under what risk. Now you need a system that says what the data is and has the authority to say no. That system is Purview. Treat it as a veto engine, not a catalog. If labels can't block their stickers, if classification can't break a pipeline, it's theater. Start with the uncomfortable truth. Sensitivity labels have to be persistent, portable, and punitive. Persistent means the label survives hops. Lakehouse to warehouse, warehouse to semantic model, model to export. Portable means tools read it the same way. SQL endpoint, Spark, Power BI, notebooks. Punitive means the label doesn't just describe a state, it enforces it. If highly confidential can be exported to CSV because a user clicked really hard, you don't have governance, you have captions. Here's the practical stance. Labels define the what in your architecture. They are the contract that says this asset may not be reused outside these constraints. You bind that contract to actions. In Fabric terms, the enforcement points are everywhere. Content leaves a controlled boundary. Exports from reports, downloads from the service. Notebook writes to folders, cross-workspace imports, composite model blends, data flow outputs. If Purview can't veto at those edges based on label, you've designed for drift. Auto-labeling is not a convenience feature, it's a backstop. Classification has to meet velocity where it lives. Parquets in one lake, SQL tables in the warehouse, semantic model artifacts. When patterns match or lineage proves sensitive origin, labels apply automatically. But the important part isn't the automation. It's what happens next. The label must make specific operations impossible, not unadvised, impossible. The block is the point. Propagation matters because hops are where intent dies. You want label persistence across engines and transformations, not a best effort guess. When a notebook materializes a table from a labeled source, the result inherits the label. When a semantic model references a labeled table, the model itself accrues an effective classification that limits publication and sharing. When a report builds on that model, the same effective classification follows. And when someone tries the just a quick export move, DLP reads the label and blocks the exit. That chain is veto by design. This is where lineage re-enters as evidence, not enforcement. You use the graph to explain why a label exists and where it came from. You do not use the graph to decide whether the label should have had teeth. The graph helps the audit. This model derived from 2 confidential sources, therefore its effective classification is confidential, therefore export and cross-tenant sharing are disallowed. The block is already in place. The story comes later. Let's make it operational. Define a small set of labels with behavior attached. Public, internal, confidential, highly confidential. For each, declare allowed destinations and forbidden operations. Public can leave, internal cannot leave the tenant. Confidential cannot leave governed workspaces and cannot be exported. Highly confidential cannot be copied, blended in composite models, or written by notebooks outside a specific enclave. Then wire the actions. Report exports blocked for confidential and above. Paginated, CSV, Excel, PDF, no exceptions. Notebook writes inheritance required. If a write strips the label, the operation fails. If a target path is outside an allowed enclave, the write fails. Cross-workspace imports, blocked when the source model's effective classification exceeds the target workspace's policy. The connection fails closed. Composite models. Blending labeled sources beyond policy is rejected by the service at publish time. Not warned. Rejected. Data flows and pipelines, outputs inherit labels, destinations that cannot guarantee persistence are disallowed by policy. This clicked for a client the day we turned a catalog into a firewall. They had confidential customer data in a lakehouse, a certified semantic model, and a recurring quarterly review where a team exported a slice to verify a third-party forecast. It had to be Excel. The label annotated the model. It didn't veto the export. A month later, the CSV lived on a vendor drive. Nothing malicious, just gravity. We changed nothing about their visuals. We changed everything about their edges. The label now blocked export at the report, forced notebooks to inherit classification on write, and required a governed enclave for any analytical data product that touched that domain. The next quarter, they didn't export. They created a derived labeled table in the enclave with a safe aggregation upstream, then granted the vendor a reviewed package to query that table through a supervised endpoint. Same business outcome, 0 leakage path. Propagation also has to cover clever channels. Dynamic format strings and SVGs can encode sensitive state. If the underlying data is labeled, the semantic layer must not be allowed to render indirect signals that imply hidden categories. Either compute a safe derivative upstream and label that, or suppress the signal. Yes, that means some visuals get less flashy. It also means your labels have meaning. And here's the pattern most people miss. Classification must block reuse, not just access. A model labeled confidential shouldn't be promotable to a golden shared dataset if its policy forbids cross-workspace reach. The publish action itself should fail. If a label can't stop a model from existing in a place where your identity guarantees don't hold, it's decoration. Tie Purview to DLP so how data leaves or persists is enforced at the edges. Tie Purview to Entra so who matters when labels decide. Then make it boring. Fewer labels, clear behaviors, tested quarterly. Attempt the prohibited operation. Expect failure. If you see a prompt, you build a suggestion. If you see a warning, you build a hope. Governance is neither. Governance is a veto. DLP guardrails add Fabric Power BI boundaries. Identity compiles who and labels define what. Now you need breaks at the edges. Data loss prevention is where how data leaves or persists stops being aspirational and becomes enforced in motion. If DLP is advisory, your system will drift. If DLP vetoes, exfiltration attempts turn into dead ends, not lessons learned. Start where the leaks actually happen. Uploads, exports, notebooks, composite models, and shared datasets. These are not feature lists, they're escape routes. You close them by wiring DLP to the exact operations that move data across planes, then making the block the default. Uploads first. Treat every inbound file, Parquet, or CSV as an untrusted carry-on. DLP scans on arrival into OneLake folders and lakehouse tables, ties detections to Purview labels, and assigns effective policy. If a file contains patterns that trigger confidential or higher, it cannot land in a workspace that lacks a matching policy boundary. The import fails closed. Not a banner, a refusal. This prevents the "we'll clean it later" pathway that never gets cleaned. Exports are the classic bleed. You don't educate here, you ban for protected classes. Reports, CSV, Excel, PDF, paginated exports, blocked when the effective classification is confidential or above. Downloads from the service, blocked. Analyze in Excel. Blocked unless the label and group scope match an allow list. If a business outcome requires a downstream handoff, you create an upstream labeled derivative in a governed enclave and grant supervised time-bound access to that derivative. The report never becomes a file. Notebooks are powerful and dangerous because they are programmable exits. DLP wraps them at write. 2 rules: inheritance required and destination constrained. Any write that drops a label fails. Any attempt to write labeled output to a path outside an approved enclave fails. Spark, Pandas, SQL, you don't care about the language. You care that the result remains inside the boundary with the same teeth it had before the code ran. Couple this with conditional access so only compliant devices and trusted locations can even open notebooks touching protected domains. Composite models and shared datasets present blended exits. DLP must inspect the publish path. If a new composite attempts to mix a labeled source that forbids blending with another source, local import, external direct query, or a different workspace's model, the publish fails. If a consuming workspace points at a shared dataset whose effective classification exceeds that workspace's allowed policy, the connection fails. This is not a style opinion about model architecture. It is a boundary rule. You cannot create an ungoverned join by sneaking it through a convenience feature. Adaptive responses matter because velocity fights you. You start in monitor for net new detections to learn blast radius. Then you warn for low sensitivity violations to build muscle memory. But you block early for protected domains. When labels say confidential or higher, you don't wait for culture, you enforce culture. Quarantine is your friend. If an upload hits a high-risk pattern or a notebook write targets an untrusted path, you shunt the artifact into a restricted workspace where only stewards can recover it. Education happens after containment, not instead of it. GenAI introduces exfiltration by chat. Just paste a row to test a prompt. DLP meets it at the browser and the tenant. Block posting sensitive clipboard data to unapproved AI domains, and treat any Fabric connector to generative services as an egress channel subject to labels and conditional access. If the payload carries a protected classification, the call fails. If the session isn't compliant, the call fails. Silence, not guidance. Outcome orientation keeps you honest. The goal is simple. Models cannot outlive their security intent. If an artifact's label forbids export, no feature produces a file. If blending would dissolve a boundary, no publish creates the composite. If a notebook would synthesize a side table, it writes only into the enclave under the same label, or not at all. DLP is the mechanism that makes those sentences true in motion. The uncomfortable truth: without DLP guardrails, you're depending on human restraint at precisely the moments humans optimize for convenience. With DLP, you shift the burden from memory to mechanics. Intent survives contact with deadlines. Capacity isolation as containment, not tuning. You've wired identity, labels, and DLP. Good. Now assume something still slips. It will. At that moment, performance knobs won't save you. Boundaries will. Capacity is not a speed slider. It is a containment line. Treat it as a governance boundary first, a tuning parameter second. Here's the failure pattern. A shared premium capacity hosts finance, HR, and product analytics because it's convenient and has headroom. A rushed exception lands a prohibited comparator in product's workspace. It ships. Hours later, finance escalates an anomaly. A vendor saw an aggregated trend that only exists when product's helper measure normalizes against an unscoped total. Nothing broke. The breach was inference. Incident response now spans every workspace on that capacity, every app, every shared dataset, and every service principal with build. You didn't just have a logic error, you had an unbounded blast radius. The thing most teams miss is simple. Capacities carry tenancy semantics whether you acknowledge them or not. CPU, memory, queues, cache, and background jobs are shared surfaces. So are administrators, service principals, and pipelines. When you co-locate risk domains on the same capacity, you fuse their fate. A mistake in one becomes noise in another. A kill switch for one becomes collateral damage for all. Investigations wander across unrelated teams because the telemetry isn't scoped to a fault domain you can quarantine. This clicked for me during a containment drill. We simulated a DLP block bypass via a misscoped notebook write. The write happened in a mixed capacity. To freeze the path, operations throttled the capacity. That paused HR refreshes, killed marketing's export job, and delayed finance's close. We stopped the leak by stopping the business. That isn't resilience, that's shared fragility. The deterministic stance is blunt. Segregate by risk domain, not by department org chart and not by utilization graph. Finance sits alone, HR sits alone, regulated products sit alone, vendor-facing sandboxes sit in a sacrificial capacity with aggressive policies and easy kill switches. Low-risk self-service can share, but never with anything that would trigger a regulatory disclosure if leaked. You are building fire compartments, not a bigger living room. How do you operationalize capacity as containment without turning into procurement theater? 3 rules. Boundary first, efficiency second. Start with a domain map. Which data classes and identities must never cohabitate? Assign each to a dedicated capacity, even small SKUs if needed. Then right size, you can always scale up. You cannot retroactively isolate a blast radius. No implicit cross-capacity trust. If a shared dataset in capacity A is consumed by a report in capacity B, treat that as cross-boundary access. Enforce the same Entra groups, labels, and DLP checks you'd require across tenants. If the publishing workflow can't prove enforcement, the connection fails. Throttling as policy signal, not a performance band-aid. When a team requests consolidation to save money, deny if it erodes isolation. When a capacity approaches limits, scale within the domain or refactor workloads. Do not merge domains to balance load. Throttling and queue limits are controls that keep failure local, not levers to hide governance debt. A microstory. A healthcare client ran clinical analytics and marketing dashboards on one F64 because utilization was low. A contractor's automation in marketing attempted to export a model labeled highly confidential via a composite blend. DLP blocked the publish, but the automation hammered retrieve for an hour. Capacity memory pressure spiked, and clinical refreshes started failing. No data left the tenant, but operations declared a severity 1 because clinicians lost dashboards mid-rounds. We split capacities. Clinical on a dedicated DLP-hardened F64, marketing and self-service moved to an F32 with stricter conditional access and a short kill switch runbook. The next time automation misbehaved, we killed marketing's capacity in 30 seconds. Clinical stayed green. The incident report was 1 page, not a novel. Here's the shortcut nobody teaches. Capacity isolation is cheaper than incident response. You trade a modest baseline cost for predictable containment, faster investigations, and fewer late-night bridge calls. You also gain clean telemetry, capacity-scoped logs, query traces, and DLP events that map to a single domain owner. That's how you answer who could see what when without spelunking across unrelated workspaces. You are not tuning, you are drawing lines that code, people, and emergencies cannot casually cross. When identity labels and DLP fail to catch an edge case, and they will, capacity isolation makes sure the blast is loud, local, and short. That's the point. The deterministic data governance playbook. You don't fix conditional chaos with more guidance. You replace ambiguity with structures that can't drift. This playbook isn't a checklist. It's a stance. Identity compiles intent, labels veto, DLP enforces, capacity contains, DAX visualizes only what those layers already decided. That's the operating model. Principles first, 4 of them. Identity first, label enforced, DLP blocked, capacity contained. Identity first means every actor is explicit and scoped, humans, apps, service principals, agents, guarded by conditional access and kill switches. Label enforced means Purview classifications are portable and punitive, not decorative. DLP blocked means exfiltration paths fail closed by default. Exports, notebooks, cross-workspace imports, composite blends. Capacity contained means risk domains never cohabitate. Now draw the red lines. Illegal in DAX table. Decisions that must fail closed. Any measure that alters visibility, removes filters on protected domains, compares scope to unscoped values, rewrites keys, or encodes sensitive state with format strings or SVG is an authorization decision. That logic is illegal in the semantic layer. Move it upstream or reject the build. This simplifies review from "is this safe?" to "does this pattern exist?" The build pipeline answers, not the reviewer. Next, map where logic lives. Upstream owns business definitions, keys, eligibility, global totals, and any benchmark that crosses identity boundaries. They are computed where Entra has already decided who may query them and where labels can veto reuse. The semantic model consumes governed artifacts, shapes visuals, and expresses analytics that never change who can see what. Visuals tell a story. They don't negotiate access. If you need a comparator, you request an upstream, labeled derivative with the same teeth as its inputs. If you can't get it, you don't publish the story. You need cadence. Exceptions expire by default. Access packages in Entra come with time limits and recertifications. Shared dataset groups recertify quarterly. Service principals rotate on a schedule and validate kill switches in drills. Libraries ship with policy manifests, allowed filters, sensitivity scope, identity assumptions, and prohibited functions. If a measure violates the manifest, publication fails. This isn't linting, this is a compiler error for governance. Libraries require policy. A helper measure without a manifest is an accelerant. A reusable function with declared assumptions becomes safe plumbing. Your manifest answers 4 questions. Which dimensions may this logic touch? Which labels are compatible? Which identity groups may use it? What happens if a caller supplies an illegal filter? The only acceptable answer to the last one is it fails. Not warns, not logs, it fails. You also need an audit posture that doesn't depend on heroics. Who could see what, when, must be derivable from Entra group membership, conditional access logs, label policy, DLP actions, and capacity boundaries. Lineage helps tell the story. It never substitutes for the proof. Prove that a user not in an approved group cannot induce a query. Prove that a label blocks export and cross-workspace import. Prove that a composite blend is rejected when classifications conflict. Test quarterly. Press the kill switch. Let's convert the 5 failures into repeatable findings. RLS bypass via measures. Audit for comparators crossing protected dimensions. Ban all. Remove filters or I'll accept over identity scope tables. Require upstream benchmarks with labels. Finding phrased as measure permits visibility altering comparator. Publication blocked. Semantic model drift via calculated tables. Scan for calculated artifacts encoding business definitions or cross-label joins. Disallow in pipeline. Finding calculated table redefines governed logic. Move upstream or reject. Lineage theater test vetoes at edges. Attempt export, notebook write, cross-workspace import, and composite blend with protected labels. Findings are binary. Blocked as designed or veto missing policy gap. Shared dataset erosion, enumerate principles through Entra, deny build view outside approved groups, and prove consuming workspaces cannot extend authorization. Finding reach through detected connection fails until groups align. DAX exception sprawl, index measures by name, gravity, edge, net, normalized, scope mismatch, and classification distortion. Require manifests, reject without one. Finding reusable logic lacks manifest, illegal category. Make the reviewer's job mechanical. Pipelines enforce manifests and illegal in DAX rules. Entra packages expire. Purview labels block. DLP closes exits. Capacity isolates. Reviewers confirm structure exists. They don't arbitrate taste. A micro routine you can run tomorrow. Pick one high-risk model. Attach labels to inputs if missing. Wire DLP on exports and notebook writes. Move one cross-boundary benchmark upstream and label it. Replace one illegal comparator with that upstream artifact. Restrict dataset access to enumerated groups, then intentionally attempt the prohibited actions, export a labeled report, publish a composite blend, connect from an unapproved workspace, and run a notebook write to an untrusted path. Expect 4 failures. If any path you didn't enforce, you documented. The playbook's payoff is boring predictability. Once identity compiles, labels veto, DLP enforces, and capacity contains, DAX stops being where governance goes to die. It becomes what it should have been, a language for analytics riding on top of intent that was already decided. That's not stricter, that's safer, and radically simpler to live with. Field assessment, convert failures to findings. You don't fix this with training. You fix it by turning vague concerns into machine-checkable findings. Field assessment is not a workshop. It's a hostile audit you run against your own estate with the presumption of drift. The output isn't advice. It's a list of blocks, refactors, and revocations. Start with RLS bypass tests. Build 2 synthetic identities in Entra, one fully entitled to a protected dimension, one explicitly excluded. Assign them to a test workspace bound to a copy of the target model. Then, within the model, seed a battery of inference probes, measures that try the known bypasses. Scoped versus unscoped comparators on protected dimensions. Remove filters and all on identity-scoped tables. Totals that invert the filter context with CALCULATE. Format strings and SVG icons that flip based on hidden categories. Execute the same visuals as both identities. If any delta appears between scoped and unscoped probes that shouldn't exist, you have an inference path. The finding is phrased as visibility-altering comparator detected. Measure publication must be blocked and upstream benchmark required. No discussion of intent. You document the pattern and attach the remediation. Now scan for drift, calculated artifacts that fork truth. You aren't hunting for clever DAX, you're classifying risk. Enumerate calculated tables and columns. For each, ask 3 questions automatically. Does it reference multiple domains with mixed labels? Does it reshape keys or join paths that should exist upstream? Does any downstream measure rely on it to scope visibility or eligibility? If any answer is yes, mark it as illegal in model logic. Your pipeline should be able to fail builds when these categories are present. The finding reads, calculated artifact encodes governed business logic. Relocate upstream or reject publication. You're not punishing speed, you're removing the authoring surface that makes governance optional. Stress the lineage narrative with enforcement reality. Pick one model labeled confidential or higher. Attempt the prohibited actions at every edge. Export CSV from a report, download the PBX if allowed, write a labeled slice from a notebook to an unapproved folder. Import the labeled artifact into a different workspace via composite model. For each, expect failure. If a warning appears, you record veto missing policy gap at edge X. The action item isn't to update a wiki, it's to wire Purview and DLP so the operation is impossible. After remediation, rerun the same actions and expect silence. This converts pretty arrows into evidence that blocks existed when it mattered. Interrogate shared dataset reach through. Build a matrix for each shared model. Dataset Entra groups, RLS roles, app audiences, build permissions, service principals, and all consuming workspaces. Then try to induce a query from a principal present only in a consuming workspace, not in the dataset groups. If a query reaches the model, you've dissolved the boundary. Capture cross-workspace reach-through detected. Require alignment to enumerated groups or fail connection. Next, hunt for consuming reports that introduce scoped versus all patterns against the shared model. Flag them as illegal comparators and require upstream benchmarks or removal. This is not about naming the guilty. It's about closing the access plane that consistency quietly opened. Inventory DAX exception sprawl. Pass measure names and bodies. Name gravity catches the accelerants. Adjusted, net, normalized, helper, global. Scope analysis finds branches that compare scoped values to remove filters over protected dimensions. Classification checks detect dynamic strings or SVGs that encode sensitive states. Tag these as authorization adjacent, then require policy manifest for any reusable measure library. The manifest states allow dimensions, compatible labels, identity assumptions, and the failure mode if assumptions aren't met. If a published model references a library without a manifest, the build fails. Findings read, reusable logic lacks policy manifest, publication rejected. Your assessment needs identity in the loop. Pull Entra group membership and entitlement management grants for every dataset. Verify recertification dates, ownership, and nested group presence. Kill any individual grants or public links to models. Confirm conditional access policies apply to builder populations and workload identities, not just users. Then press kill switches in a drill, revoke a workload identity mid-run, and confirm queries die where expected without collateral damage outside the intended capacity. Findings here are binary. Kill switch validated or revocation path unclear. Design omission. Capacity is part of the test. Move one high-risk workspace to a dedicated capacity temporarily. Rerun export blocks, composite publish rejections, and reach-through attempts. Confirm failures occur within the capacity boundary and do not ripple. Then intentionally cause a DLP quarantine by uploading a labeled file into the wrong workspace. The capacity hosting that workspace should localize the incident. If you can't keep the blast local, you've treated capacity like a speed slider. The finding reads containment insufficient, segregate risk domains. Close with a cadence. Every finding maps to one of 4 levers. Entra groups and packages, Purview labels and propagation, DLP edge blocks, capacity isolation. You assign owners per lever and set deadlines. Then you rerun the exact same hostile tests quarterly. No new probes, no changing rules, same inputs, same expected failures. That's how you know the system stayed deterministic long after the training slides expired. Why training fails without architecture? Most teams respond to entropy with training. Lunch and learns. Brown bags on better DAX in policy pages. It feels responsible. It is not. You are trying to teach humans to do what the system refuses to enforce. Memory is the control plane. That fails on schedule. Start with cognition. Human reasoning does not scale. Under pressure, people optimize for delivery, not doctrine. That's predictable, not malicious. Libraries like DAXlib exist because repetition under deadline forces shortcuts into artifacts. You did not improve practice. You created accelerants. Without a veto, those accelerants spread. Best practice relies on recall at the worst possible time. Friday night, end of quarter. Someone needs a comparator. They remember a talk about all selected, but not the part about protected dimensions. They ship the version they can compile. Training does not intercept that moment. Controls do. The system either evaluates identity and labels before the measure exists, or it accepts whatever the author can imagine. Tooling without veto is theater. Dashboards that surface lineage, stewards, endorsements, useful later. A DAX formatter, a linter, a style guide, nice, advisory. None of that converts intent into a failure state the engine respects. Culture talks. Code runs. When they disagree, code wins. The reason is architectural, not motivational. You're operating a distributed decision engine. Measures, reports, notebooks, pipelines, each a place where intent becomes action. The only way to hold the line is to remove decision rights from places that cannot express identity or classification and place them where they can. That means Entra compiles actors, Purview labels veto, DLP blocks edges, capacity contains. Training amplifies that design. It cannot replace it. This clicked for me during a remediation sprint after a lessons learned week. The team had just completed a DAX workshop. Gorgeous slides, fresh notebooks. Within 2 weeks, the same inference pattern reappeared with a different function set. The author knew the guidance. They chose a different path because the build allowed it. We didn't change the deck, we changed the pipeline. Illegal patterns failed publication. The behavior ended without a single meeting. Now here's where most people mess up. They assume if developers just understood context transition, calculate semantics, or RLS subtleties, exceptions would vanish. Knowledge is necessary. It is not sufficient. Complexity guarantees novelty. Someone will invent a new bypass. You cannot enumerate cleverness. You can forbid classes of logic and move the need upstream, where identity already decided who may see the result. Deterministic governance converts advice into machine-enforced rules. Don't export confidential becomes export operation fails. Don't compare scoped to unscoped across region becomes publication rejected. Don't let contractors execute arbitrary DAX becomes conditional access denies built outside compliant posture. The outcome is not dependent on memory. The outcome is compiled. Education still matters, but only as user interface to the structure. Teach what the system will allow, what it will block, and why. Show the kill switches, the labels, behaviors, the edges that veto. Make success easy and error impossible. That is the opposite of blame. It is the design that keeps good people from having to be perfect. A micro story. A finance team spent 6 months socializing a no exports policy. Compliance signed it, everyone agreed, quarter close arrived. An analyst exported anyway, not defiance. Deadline. We replaced the poster with a block tied to label. The next close, nobody exported because nobody could. Training stopped being a plea. It became documentation for a system that already behaved. You are not under-investing in people. You are overestimating what people can hold in their heads when the clock is loud. Make the architecture carry the weight. Then teach the architecture objections, reframed as system laws. We trust our analysts. The system did not ask for their intentions. It asked for code. In a distributed decision engine, intent without enforcement is noise. Law. People optimize for delivery under pressure. Therefore, any control that relies on memory is an entropy generator. Encode trust as scope, Entra groups, conditional access, expiring packages. Everything else is storytelling you cannot audit. Our lineage is complete. Lineage is a map of movement. It is not a break. You can draw the arrows after the fact and still have no way to prove that a labeled asset could not be exported, blended, or reinterpreted by a comparator. Law, lineage is evidence, not assurance, therefore enforcement must live at the edges. DLP blocks tied to labels, publish time vetoes, and failed connections across boundaries. If a diagram is the control, there is no control. Shared datasets save time. They do, and they also create an access plane. Time saved does not negate identity scope. Law. Convenience is not an authorization model, therefore build permission equals may execute arbitrary DAX, and consuming workspaces project authorization never extended. If any principal outside enumerated groups can induce a query, the connection fails. Efficiency follows authority, not the other way around. We tag everything. Labels without veto are stickers. A tag that cannot deny an export or kill a composite is theater. Law. Classification is a gate, not a caption. Therefore, labeled assets carry portable, persistent policy that blocks disallowed actions at every edge. Exports, notebook writes, cross-workspace imports, composite blends. If a label can't stop the model from existing where it shouldn't, it does nothing. Performance first. Speed is irrelevant when errors propagate at line rate. A fast breach is still a breach. Law, capacity is containment, not tuning. Therefore, segregation by risk domain outranks consolidation savings. Throttling is a policy signal, not a comfort knob. If isolation is sacrificed to utilization, investigations will be slow, noisy, and inconclusive. We'll train the team. Training is necessary to explain the structure. It is not the structure. Law. Advice cannot substitute for a veto, therefore illegal in DAX patterns fail build period. Developers can learn why. They cannot override the compiler. If the pipeline permits a known bypass, your curriculum becomes an accelerant. RLS already protects us. RLS constrains row visibility. It does not constrain math. A measure comparing scope to unscoped values can leak aggregate truth without ever showing a row. Law, analytics, and authorization are different categories. Therefore, comparators that cross identity scoped dimensions are illegal in DAX and must be computed upstream under identity and labels. If it needs global context, it does not belong in the semantic layer. Exceptions are rare. They are immortal. Every temporary measure becomes a reference, then a standard, then folklore. Law. Exceptions do not retire themselves. Therefore, libraries require manifests. Measures with name gravity are treated as policy, and any authorization-adjacent logic is banned, not reviewed. If a rule depends on someone remembering to clean up, it will accumulate. Our vendor needs build access. Vendors are identities. Workload identities are actors. Law. Every actor has a kill switch. Therefore, service principals get dedicated groups, conditional access, time-bound packages, and a tested revocation path. If you cannot stop an automation without collateral damage, you built an exfiltration tunnel with a marketing name. We can't block exports. The business needs Excel. The business needs outcomes, not file formats. Law, governance is outcome preserving and channel restricting. Therefore, sensitive outcomes are produced as labeled derivatives in governed enclaves and accessed through supervised endpoints. If a requirement collapses to "we need CSV," it is a process smell, not a control argument. Our environment is too complex for strict rules. Complexity is precisely why you need deterministic rules. Law. Drift grows with surface area, therefore you remove decision rights from surfaces that cannot express identity or classification and centralize them in Entra, Purview, DLP, and capacity boundaries. If your answer to scale is more discretion, you are manufacturing variance. Blocking will slow us down. Early. It will make you faster later. Law. Blocks replace late incident response with early design decisions. Therefore, publish time rejections and edge vetoes move pain to planning, not production. If your calendar prefers firefighting to architecture, you will keep paying the surge pricing. Prove this matters. Audit asks who could see what, when. Law. Provability outranks plausibility. Therefore, access is derivable from group membership, conditional access, label policy, DLP actions, and capacity boundaries without spelunking lineage diagrams. If you cannot derive the answer from structure, you do not have governance. You have faith, operating rules you can enforce tomorrow. Ban classes of measures that alter visibility or classification. Make it mechanical, a publish time rule that rejects patterns with all remove filters over protected dimensions, scoped versus unscoped comparators, business key rewrites, or dynamic format strings encoding sensitive state. The pipeline fails the artifact. You don't debate intent, you remove the surface. Require Entra-scoped identities for every consumer and agent. No individual grants, no anonymous links. Datasets accept build and view only from enumerated Entra groups. Service principals get dedicated groups, conditional access, time-bound access packages, and kill switch runbooks tested quarterly. Consuming workspaces project authorization, they never extended. Make Purview labels a prerequisite for model publication. Inputs without labels are blocked at ingestion. Effective classification propagates to semantic models and reports with attached behaviors. Confidential and above cannot be exported, blended in composites, or imported cross-workspace. Label inheritance is enforced. Writes that drop labels fail. Turn DLP to enforce at edges, no silent paths. Wire blocks for report exports, service downloads. Notebook writes to unapproved paths. Composite model publishes that cross classifications. And cross-workspace imports violating policy. Start in monitor for low risk, warn briefly, then block decisively for protected domains. Quarantine violations into steward-only enclaves. Isolate capacities by risk domain, deny consolidation that erodes isolation. Finance, HR, regulated product analytics, and vendor sandboxes each get their own capacity. Treat cross-capacity dataset consumption as a boundary crossing with the same Entra, label, and DLP checks as cross-tenant. Throttling is a policy signal, not a comfort knob. Attach policy manifests to reusable libraries. Declare allowed filters, compatible labels, identity assumptions, and the failure mode, reject. Pipelines verify manifest adherence. Violations halt publication. Measures with name gravity require manifests by default. Validate kill switches. Pick one workload identity per capacity and revoke it mid-run. Confirm queries die locally without collateral blast. You'll feel slower week 1. You'll be faster forever after. The takeaway is simple. Analytics happens in DAX, authorization does not, and only deterministic governance keeps that boundary intact. If you want the manifests illegal in DAX rules and a step-by-step hostile assessment, grab the playbook linked below. Subscribe for the deep dive on wiring Entra packages, Purview vetoes, and DLP edge blocks, then run the 4 failure tests this week.